everyone, it's Miss Williams again. We are on our second video for exponents and log units. This time we're going to be talking about log expressions and some of the rules. Alright, so the first thing you have to know is how you switch from exponential, having an exponent form, to having it in log form. Alright, last unit we learned about inverse functions and how we find them. So what would be the inverse of an exponential function? Well, it would be logs. So let's look again at an exponential equation where it's b to the x power is equal to a. This is only going to work if b is greater than 0 and as long as it does not equal 1. So the b part of this equation is actually called the base. Alright, so when you look at log equations, you would read this as log base b of a is equal to x. Here, the base is also represented by the letter b. Alright, so what if I wanted to switch from exponents to logs and logs to exponents? Well, the first thing you have to do is remember that the base stays the base and the other two things switch sides. That's how I remember how to switch them back and forth. So if I had 4 to the x power is equal to 14, it's hard for me to know what x is, but if I could change it to log form, then I could put it in my calculator and find the answer. So the base is 4. So the base is going to stay the base and the other two things switch sides. So I end up with log base 4 of 14 because the 14 and the x switch sides of the equal sign. So log base 4 of 14 is equal to x. I can put that in my calculator and I'll show you how to do that when you're in class. And the answer is x equals 1.09. Alright? Alright, some of the properties of logs. The first one is the common log. Logs with a base of 10 are called the common log, and there is no need to write the base of 10. 10 is like the understood base in logs. Okay? So log with base 10 of x, you can just simply say it's log of x. There's no need to write the little 10. Also, if you don't see a little 10, it's understood that the base is 10. So it's something you'll need to know. Okay? The product property of logs. When two logs have the same base and you're trying to add them, the two logs can be written as one log, let's just say log, not long, one log by multiplying the big numbers. So in other words, if you had log base 4 of 5 plus log base 4 of x, since we're adding, we're going to combine the big numbers, the 5 and the x together, and get log base 4 of 5x. Okay? Two more properties. The quotient property of logs. When two logs have the same base and you're trying to subtract them, the two logs can be written as one log by dividing the big numbers. So log base 6 of 8 minus log base 6 of 16. So we're going to take the 8 and the 16 and we're going to divide them, and they have to stay in this order, the 8 and then the 16. Okay, so 8 over 16 we all know is the same as 1/2 or 0.5. The power property of logs, an exponent on the big number can be brought in front and become the coefficient. So in other words, if you have log base 5 of x to the third power, you can take the exponent to the third and bring it in front of the entire word log, and now it becomes a coefficient. And one more property that we're going to talk about today is the change of base formula. With any log, you can change the base to whatever you want it to be so that you can simplify things more easily. Remember that the base number goes on the bottom. So if I had log base a of x, I can make the base be anything I want, but it's going to split up my original base and my original big number. So the big number goes on the top, the base on the bottom. Base on the bottom. Remember that. Alright, so here's some example problems. Can you write each log in exponential form? And then solve it. So we have log base 3 of x is equal to 4. So if I want to change it to exponential form, I have to remember the base stays the base and the other two things switch sides. So the 3 is my base. So and the x and the 4 are going to switch sides. So it's 3 to the 4th is equal to x. 3 to the 4th is the same as 81. So x equals 81. Number 2, log of x is equal to 4. Well, what's my base? Oh, that's right. When you don't see a base, the base is 10. So the base stays the base, the other two things switch sides. So it's 10 to the 4th power is equal to x, and 10 to the 4th power is 10,000. What if I wanted to go the other way? Can you change from exponential form to log form? So again, base stays the base, and the other two things switch sides. So my base here is 5. So I'm going to write log with a base of 5, and then the x and the 4 switch sides of the equal sign. So log base 5 of 4 is equal to x, and I'll show you how to put that in the calculator next class period. Same with the other side. 10 to the x power is equal to 175, so I can just, since 10 is my base, I don't have to write a base of 10, so I could just write log 175 is equal to x. Alright, a couple more example problems. Can you write it as a single log? So I noticed that my bases match, In number 1, my bases match. They both have the base of 2, and I have 5 and 25, and I'm subtracting. So when I subtract, I can take those big numbers and combine them into division. And 5 over 25 reduces to 1 over 5th. So log base 2 of 1/5. All right, number 2, 4 times log of 2 plus log of 3. So I notice I have the same base. The base is 10. I don't have to write that. But then I notice before I can combine my two logs, I do have a coefficient of one of them. So I need to get rid of that coefficient. So the coefficient can actually become an exponent. So I'm going to take the 4 that's just in front of the log 2, and I'm going to put that 4 on the 2. 2 to the 4th power. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this really says log of 16 plus log of 3. Now I can put them together and write them as a single log. So what am I going to do with the 16 and the 3? I'm going to multiply those. So 16 times 3 is 48, and I could put that in my calculator and get a rounded answer. All right. Thanks for listening today. I will see you in class next period.